Hi guys, so today we're going to do this Atcoder beginner contest 202. So I'll do the usual screencast thing, basically explain while I solve. And these contests are like really good for beginners because the initial few questions are like really easy. So yeah, so that will be really nice for beginners. If you haven't registered an Atcoder, you should do that. You should totally do that. And yeah, so let's go. It's not loading. Okay. Yeah, so probably this will be really easy. Roll three dice, and these are the numbers. So find the sum of numbers on the bottoms of faces. Okay, so basically, if on the top if you have like 2, then on the bottom you will have 7. So I think 21 minus the sum of all this will be the answer. Okay, so like here I have 8. So 21 minus 8 is the answer, right? Okay. Okay. Yeah, this should work. Green means that it's correct on all the sample test cases. So let's submit this. Cool. Let's see the second problem. We got AC on this one. Let's see the second problem. You are given a string consisting of only these numbers, and you can rotate it 180 degrees and print the results. Okay. So reverse and 0 stays 0, 1 stays 1, 6 and 9 get replaced. Right. That's it. Okay, so basically we have to perform these things that they're saying. Okay, so we take a string s, we see in s, and then go through each character by character like this. So let's reverse the string first. Okay, after reversing, 6 should become 9 and 9 should become 6. Okay, so if c is 6, then make it 9, and otherwise if it is 9, then make it 6, otherwise don't do anything with it and just print the string. Okay, yeah, so it works on all the samples. So let's submit this. Right, let's take up the next problem. So we are given 3 sequences consisting of integers. So this is the input format. Okay, how many pairs satisfy this thing? Okay, this was AC. Yeah, so basically we have to tell how many pairs satisfy AI equals BCJ, right? Okay, so how do we do this? I think it would be good to maybe like we can have all the values of BCJs, right? Uh, like replace the array C with the BCJ, and then we can have the frequency of each element, and for each I we can see how many times that element is present in the other array, right? So something like this. Okay, so we have n first of all, then we have 3 vectors A, B and C. We need to take input all of these. Right, so this is one of them. Second and third. Okay, then what we can do is we can just replace them like this, right? Okay, so we can say x equals b of x minus 1, right? So now c will become this thing bcj, right? Okay, then what we can do is, right, so we would just want the frequency of all this. So yeah, so let's take another vector for the frequencies, I think. Okay, okay, so this is storing the frequencies. So let's say frequency of x plus plus. Now let's say answer equals 0, and then we simply do something like, let's iterate through a answer plus equals the frequency of x, and if you print this, I think this should be correct. This is an infinite loop. Let me see. Oh, I didn't take input. Okay. Yeah, so it runs on all the samples. Let's submit this. Right. What is this? A B A B A ba A ba ba whatever. Okay, so we got 3 problems by now, and we are on the 4th now. Okay, so we are given 2 numbers a and b, and among the strings of this length containing a occurrences of a and b occurrences of b, find the string that comes kth in lexicographical order. Okay, right. So I think for this one we need to like move from left to right and have like we need to have some count for how many we cannot iterate, right? Uh, hmm. Yeah, so we kind of need to have something like just a second, 2 to power 30, right? So we need to know how many strings can be formed by putting a there. That can be done using some simple NCR kind of stuff, right? Binomial coefficients. A plus B C, A plus B C A, something like that. And if that is good enough, then we put A, otherwise we put B, something like that. Okay. So first of all, let's do one thing. Let's just store all the NCRs. Okay. Let's just store all the NCRs first. So that, let's take NCR. Okay. Size, let's take 60 something. Okay. 60 like this. I think. Yeah, anyway. So wait a minute, won't this be too big? 60 to the power 60, yeah, and not very big. Okay. So we take this and then we have to store all the NCRs like this. So we know that NCR 0, 0 equals 1, I think. Okay. Now just iterate. Okay, let's just iterate on n like this from 1 till 61. So we want to store NCR n comma r, something like that, right? So let's iterate on r also. Okay, so we first of all we know that NCR of n comma 0 equals 1, right? After that, for anything else, we do it something like this. NCR n comma r. For that we will need to iterate on r also. Just a second. We need 2 things. That we know 2 things, that NCR of n comma n, and n comma 0 equals 1, and for the R we will iterate from R equals 1 till n minus 1 basically, and NCR of n comma R equals NCR n minus 1 R, NCR n minus 1 R minus 1, right? Something, I think Pascal's triangle, Pascal law, something like that is called, right? So let me just check for once if it is correct or not. So let's see what's the value of 5C2. It should be 10. So if this is 10, then that means we have done it correctly. Okay, let's do 6C2 also. 6C2 is I think 15. And just for confirmation, let's do 6C3 also, which is I think 20, right? 20 only. 120 by 620, yeah, exactly. So NCRs we have stored correctly. Now let's take the inputs ABK, in ABK. Okay, cool. Now what do we have to do? Okay, yeah, we have to decide immediately whether to put A here or B here. Okay, so total length will be A plus B. Okay, now we have to put n characters here. Okay, now we have to immediately decide whether to put A here or to put B here. Okay, so we need to know how many strings we will have if we put a here. Okay, so if we put A, so we need to know how many strings we have, right? So let's say int count equals NCR A minus 1, because 1A we have already used, plus B, A minus 1 plus B and B, right? So this is the number of strings that will yeah, so this is the count of the number of strings that we can make after this, right? So what can we do with this? We know that if we have k, like if we want the kth string, right? So if we want the kth string, and we can make k strings by putting a here, right? So obviously we will put A here, otherwise we will put B, right? So if let's say if count is smaller or equal to k, no, I think if count is greater or equal to k, that means we put a here. So we put A here. So for that I will just print A, right? But otherwise what we will do is we have to put B here, right? So put B here, because if we put a we won't be able to make at least k strings, right? And we want the k string. But when we put a B, then some things will change, right? So earlier I said I want the kth string, now I don't want the kth string, now I want k minus count, like this string. Okay, so yeah, then it will work, and I think it should give me the correct answer. Let's see. No, I think this is wrong. Yeah, okay, just a second. What if k equals 1? Okay. Three. Wait a second, why am I printing A everywhere? Oh, sorry, yeah. So I didn't decrease A after this, right? So I should do A minus minus because I decreased the A. I have already used up A, and here I should do B minus minus. So now I think it should be correct. Right, so samples worked, and my other custom made test cases are also correct, I think. Okay, so let's submit this. Right, so idea is pretty simple. Something like, first let's store the NCRs, then see if we put A, are we able to make at least k strings or not. If we can do that, then print A here and subtract the number of A's. Otherwise print B here, subtract the number of B's by 1, and yeah, Okay, so it got AC. Let's see the problem E. So now at this point it should be a little tougher, right? So E and F are a little tougher usually in Atcoder beginner contest. This is like a non-beginner kind of stuff probably, but let's see. So we have, I think, a tree with one as the root, and parent vertex I is Pi. We are given Q queries. Given UI and DI. Okay, so I think something UI and DI is given to us. Vertex UI is in the shortest path from U to the root. Okay. Okay. There are exactly DI edges in the shortest path from U to the root. Okay, I think this is quite obvious. So it is something like we want the number of vertices at a given depth in the subtree of this thing. In the subtree of what am I saying? Yeah, so we want the number of vertices that have the depth di and are present inside the subtree of ui. There are, I think, multiple ways to do it. It could be done using, I think, SAC, or I think there are a lot of ways to do this, right? Using Euler tools, many ways actually to do this. Let me just pick a way that is easier to explain. Okay, so if we use Euler tools, then what we will have to do is we will have to see. Yeah, no, that's clumsy. I think SAC will be the best here. And maybe there's some easy way to do it offline. Just put the queries in the vertices. And no, I think SAC is the easiest way to do this one. Okay. Right. So maybe I'll explain SAC later after this contest because it will take too much time. What's happening? Okay. Okay, so SAC or Euler tool. Let me see. Maybe with Euler tool it can be done more easily. So with Euler tool, I will add in the tree and I have the subtree range. Then I just want how many this thing is present there. Right. Okay. Yeah. Okay. Yeah. Fine. With Euler tools, it is better. Okay. So I have P5 plus 5. So I'll explain as I'm writing. So first we keep a tree, then n vertices, okay, and okay, the parents we are given. So we can just do something like VP dot pushback I. Okay, so we have made the graph now. What do we do next? We will have the queries, right? So we will answer the queries later. We will answer the queries later. Let me just take the input. We will answer them later. For now, let's do some pre-processing. Okay. So for the pre-processing, I will use a DFS. Void DFS int whatever the vertex is. Now let's go to the children of the vertex and do a DFS on them also. Okay. So basically, I need to have the start time and end time. So start time, end time, and time equals 0, right? So basically, I'm storing the time at which I enter a node. So let's say the start time of Z equals time plus plus, and end time of that vertex equals 0. Sorry, time, right? So I'm storing at what time I enter a node and at what time I exit a node. So this technique is actually called tree flattening or Euler tour or something like that. So oh yeah, so that's what I'm doing. Apart from just storing this vertex, let me also keep track of the depth, right? So for the root, obviously the depth will be 0, and everywhere else I will just send depth plus 1. Okay, and then let's keep another vector. Okay, so in this I will store d of x will store start times of vertices with depth x. Okay, so d of x will store start time of vertices with depth x. So let's do that. Let's say d of depth dot pushback. Let's store the start time of this vertex here. What is the start time of this vertex? It is z, start time of z, right? So I've stored the start time like this of everything. Okay, so basically I have so this was the entire thing that I was trying to do. First mark the start times and end times of everything, and keep a vector, keep multiple vectors, such that the xth vector will store the start times of the vertices which have the depth x. Okay. So now let's see how we will solve a query. So first of all, let's call the DFS from the vertex 1, I think. Yeah, 1 is the root. Okay, so now start time, end time, and everything is stored. So now how will I solve this thing for u and d? Okay, so okay, need to rename this d with something else. Let's just keep capital D. Okay, so I want the vertices that are at depth d, at depth capital D, right? So this thing will store the vertices that are present at depth capital D. Okay, so in this, what do I want to find? So I want to find the vertices. This is storing the start time of all the vertices, right? So if it is in the subtree of my subtree of u, then it has to start after u and end before u, right? So like it should lie in the range, and time u, like from start time to end time u, it has to lie, right? So let's say something like int l equal to start time of u, and r equals end time of u, right? Something like this. So it has to lie in this range. Okay, so yeah. So for this we will use binary search, because the start times are already sorted in increasing order, because we inserted them like that. So let's just say that lower bound of end time minus lower bound, wait a second. Wait a second. Right. Just a second. Lower. Obviously, we need lower bound, but we need to subtract, right? So at least one attempt that comes after that has to be taken, so that we can subtract it with that, right? Something like lower bound all of dd comma l, right? So this will give us the first vertex which has the start time greater or equal to l, right? And now I want the first vertex which has end time greater or which has start time greater or equal to r, right? Something like this. It probably should work. All of dd, something like this, r. Yes. So I think if we subtract these, this should give me the correct answer. Something like this. Answer to this query will be this thing. And if I print it like this, maybe that will be correct. Okay, so I think there was one test case and that one is correct. So let's submit this. I will explain this one a little more after the contest. Okay. Yay. Okay. Yeah.